Good morning, students. I will be starting with 2.6 numerical. So this being a combined, the batches have been clubbed. The 2.6 numerical I will read. Two clocks are being tested against a standard clock located in National Laboratory. Just go through it. In the meanwhile, I will be writing on the board. The board takes some time. So let me correct it myself. So instead of doing it, asking you to come over to the board, you just go through the things. Let me write the clocks which have been already highlighted on the screen. Go through the screen. I'll be putting on a board, right? The moment I keep it, it's going to be a more interesting. So we have a days, weekday. It's clock 1. It's clock 2. It's Monday. It's Tuesday. It's Wednesday. It's Thursday, Friday. Then I had Saturday. Then a Sunday. Monday clock 1 is read as in terms of, we have taken in terms of, I hope you remember, it's something like 12 noon, 5 seconds. Then I think its second one is also 12 noon, 1 minute, 15 seconds. 12 noon, 1 minute, 15 seconds. Then the third Wednesday, I'm talking about clock 1 I'm writing. I suggest do copy the notebook. It is 11:59:08. 11:59:08. 11:59:08. Next, of course, it is 12:150. 12 noon, 1 minute, 50 seconds. Then the Friday I need to write, it is 11:59:15. 11:59:15 seconds. Saturday, yes, I'll be writing 12:130. 12:130. Then, of course, Sunday it is 12:119. Sunday it is 12:119. Yes. Similarly, I need to write for clock 2. When you read for clock 2, it shows 10:15:06. 10:15:06. Then I had 10:14:50. 10:14:59. 10:14:59. 10:14:59. So I need to make it big. So it's not, yes, let me make it big. So for me, it becomes very simple. 10:14:59, 10:15:18. 10:15:18. Then I had 10:15:07. 10:15:07. 10:14:53. 10:14:53. 10:15:24. 10:15:24. Yes, 10:15:11. 10:15:11. Let me cross check. It is 10:15:06, 10:14:59, 10:15:18, 14:59, 15:18, 10:15:07, 10:14:53, 10:15:24, 10:15:11. Similarly, 12:119, 12:130, 11:59:15, 12:150, then 11:59:08, 12:115, 12:05. Yes. Let me stop. Let me read the question. If you are doing an experiment that requires precision time interval measurements, yes, this is going to be interesting. Which of the two clocks will you prefer? Means among the two clocks, which is preferred? Let me go back and let me start on a board. Okay, I think, yes, the screen is, let me stop. Now cross check. Yes, the whole numerical is written on a board. You have a numerical which tells something about accuracy and precision. This numerical, instead of taking about accuracy, we talk about precision. Means I have two clocks. These two clocks are compared with standard clock. The standard clock is reading every day, it reads at 12 noon. Means 12 o'clock, 00 minutes, 00 seconds. It reads at 12. Means you have a standard clock every day, whether it's a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. All the weekdays, it reads as 12 noon. Whereas when I check my clock 1 and clock 2, let me go to clock 1. When I check clock 1 Monday with respect to standard clock, my clock 1 reads 12 noon, 0 minutes, 5 seconds. Similarly, Tuesday it reads 12 noon, 1 minute 15 means 5 seconds it is ahead. And now it is 1 minute 15 seconds ahead. It is reading, showing different value. It is called a variation. Wednesday, when clock 1 is compared with again standard clock, it shows 11 hour 59 minutes. It is lagging now. It was ahead. The variation was now minus. Thursday, 12 hour, 1 minute 50 seconds. Similarly, Friday, when I compare the standard, Friday also 11, 59, 15. So 12, 1, 30. So when you compare these days, Monday, Tuesday up to Sunday to standard clock, clock 1 average value is called a 12. 12 is called an average value. Average value is close to the 12 noon, but the variations are large. Means what I mean to say, clock 1 is showing 12 noon, standard clock is also showing 12 noon. But the variations are 5 seconds, 1 minute, 15 seconds, 1 minute means 60 seconds, 60 plus 15, 75 seconds. I can write. So in that way, what is the variation? You can call it as inside a bracket 5 seconds. Here 75 seconds. Again here it is less, 52 seconds less. Now it is 1 minute 50. It is 110 seconds ahead. So again it is 45 seconds slow. So it is 1 minute 30, 90 seconds. It is plus 90. Then again 1 minute 19 seconds. Again 60 plus 79. So when you look at the variation is plus 5, plus 75, minus 52. The variations is large. When I cross-check the 7 days, Monday to Sunday, I can notice this is the largest variation. It is called positive, plus 110. This is minus 52. I need to take the bigger value, large variation on a particular day. This is a large variation, 12 noon, 1 minute 50 compared to all other days. So it is called 110 seconds plus, so plus 52, because even though I have written minus, it is lacking. Instead of reading 12 noon, it is showing 12 noon, 59 seconds, sorry, 59 minutes, 8 seconds. I need to take minus 52 becomes plus. So finally, variation for clock 1 variation, the variation is something like 110. So we write like this, plus 52, totally it is going to be 162 seconds. I can say, when I cross-check clock 1 over a weekdays to the standard clock, this is called variation. This is called variation. Clock 1 shows this much variation. Similarly, when I cross-check clock 2 with a standard clock, its average value is 10 hour 15 minutes. Instead of showing it is a 12 noon, it is showing 10 hour 15 minutes. If you take 10 as a reference marker, 10 hour 15 minutes 00 second, instead of taking 12 noon, if you compare clock 2 with this standard, 10 hour 15 minutes, it is a 6 seconds. Now 14, it is only 1 second, minus 1 second, again 18 seconds, plus, again plus 7 seconds, again minus 7 seconds, again 24 seconds, again 11 seconds. What it means, instead of taking this clock 2 with 12 noon, its average value is error, means it is called zero error. The starting point is mistake. But when you check the Monday, Tuesday up to Sunday, the variations are very, very less. So when I talk about clock 2 variation, it is plus 6, minus 1, plus 18, again plus 7, minus 7. So I need to take plus 18, then I need, okay, sorry, it is plus 24 I need to take, and minus 7. So together it becomes 24 plus 7. It becomes 31 seconds. So when you compare variations, it is called variations. Clock 1 variation is showing 162 seconds. Clock 2 is showing 31 seconds. When it comes to variation, clock 1 is good. Clock 1 is good. Hence, for precision measurement, for precision measurement, clock 2, I hope, yes. For precision measurement, clock 2 is preferred. For precision measurement, clock 2 is preferred. The error which I am talking, it is showing 10 hours, 50 minutes. You adjust the knob, make it 12 noon. So once it is adjusted, this clock, the variations can be minimized. Means since variations are less, this clock 2 is preferred with clock 1 when your goal is precise measurements, not accurate measurement, precise measurement. When I talk about precision, for precision measurements, the variations over the weekdays, should be minimum. So when clock 1, you check the variation over a weekdays, it is 162 seconds. That's why I have written. You have two values. One is your, yes, Wednesday and Thursday, it is showing large variation, 110 seconds, and you have 52. So both you cross check, it is 52 seconds here, it is 110. So when you come to these two things, it is again your Friday and Saturday, it is showing variation, that to variation minus 7 seconds plus 24. So when variations are taken into account, clock 2 shows less variations, clock 1 shows more variations. So hence for precision measurements, we prefer clock 2 in comparison to clock 1. This was an explanation. Good. You have any doubt, please let me know. Sir, how to take 24 and 7? Okay. Yeah. So next numerical for our study is 2.7, where we measure the period of oscillation of a simple pendulum, and the values are, the values will be listed on the board. Then definitely I'll be taking up, yes, the values. The values are typically 2.63, 2.56, and 2.635642. Let me write simple pendulum. Then I will, yes, you have an experiment simple pendulum. You perform an experiment where the observations are found to be the time period. Yes, the time periods over different days. It is called first one, T1, T2, T3, T4, and T5. Let me, yes, let me show you, yes, the board, and let me cross check. Yes, I hope you can see the board. I am first value 2.63. It is seconds. The second one 2.56 seconds. The third value is 2.42, 2.42, 2.71, 2.80. Yes, these are the values. Let me go back. Yes. Yes, I hope. What is the question? The simple question is, you have a simple pendulum where we have taken the time periods. It is called time period. Time period is time for one oscillation. Time for one oscillation. The time taken by one complete oscillation, simple pendulum looks like this. Let me have a line. Yes, the line is visible. Yes, I had a fixed end. So one end of the thread is fixed here. You just have a metal bob. The length is going to be L. So think this is the ends. It is going to oscillate. When it is going to oscillate, so think it is here. It is mass. So take for it starts here. It goes to the left, then comes back to the same position, goes back and comes back. This is called, or you make a starting point. It goes this way, then it comes this back. The time taken to move from the starting point, start to and back motion, it moves in the forward direction, backward direction. The time taken to move from here to here and coming back to the same position is called time period, and which is taken for one oscillation. It is called one oscillation. You just pull the bob, you release it. It goes to and comes back. So it is called back motion, forward motion and backward. The time taken to move from here to here and coming back is called time period. What is time period? Time taken by the bob to complete one oscillation. It is called time period. So first measurement I did, it is 2.63. Then similarly second 2.56, 2.42, 2.71, 2.80. I had 5 time periods. Then the question is, what is the absolute error in this experiment? We have done an experiment. First reading, first oscillation takes 2.63, second oscillation takes 2.56, 2.42, 2.7 and 2.80. Now the question is, what is the absolute error in measuring the time period? What is the relative error in measuring the time period? What is the what is the percentage error in measuring time period? So time period is a physical quantity, time is a physical quantity, second is a unit. When you do experiment of measuring time, what are the error associated? What is the absolute error? What is the relative error? What is the percentage error? Let me start the first one. Before calculating absolute error, let me write what is the mean time period. For calculation of a mean time period, as all are familiar, now mean time period. What is mean time period? Mean time period is defined as something like, you call it as T mean. Mean time period is equal to adding all the observations, 5 observations, and dividing it by 5. Like T1 plus T2 plus T3 plus T4 plus T5. Adding all the individual time periods and divide it by 5. So first value is 2.63, 2.56. Go on adding all this, you'll get, if I'm correct, you will get 13.12. Cross check. 3, 6, 9, 9 plus 2, 11, 11 plus 12, 12. 12 means 2, carry 1. 7, 7, 5, 7, 5 of course, 12, 12, 16, 16, 1, 7, 23, 23, 31, 1, 3 carry. 3 carry means again 3. 1, 2, 3, 4, 5, 10, 13. That's why it is 13.12 divided by 5. When you do the simplification will give you 5 2 ja, 10, 3 remains, it becomes 31, 5 6 ja, 30, 1 remains. Then again, you have something like 12, 12 means again 2. Then again it becomes 20, it becomes. All your time periods are second decimal places, first decimal, second. So I will end up with second decimal place. I will be neglecting this. My answer is going to be T mean. Mean time period is going to be 2.62 seconds. I will take it as. Why this is required? This value is required for measuring absolute error. Now I define absolute error. Absolute error. What is absolute error in delta T1? We know that delta T1 is measured as T mean minus T1. So similarly, delta T2, delta T3, delta T4, T5, I go on doing. When I do this mathematical calculation, you'll get some values. Let me write this delta mean here. Yes, I'll be writing it here. It's going to be very interesting. So this formula gives me delta T is equivalent to T mean minus Ti. What is Ti? This is going to be Ti. Delta Ti equal to T mean minus Ti. I will take the running values. Let me write the first one. Delta T1 is equivalent to 2.62 minus 2.63. Like 2.62 minus 2.63. You will get close to minus equal to, it's visible? Yes, I will be writing minus 0.01 second, minus 0.01 second. Similarly, when you write delta T2 is going to be again 2.62 minus 2.56. 2.56. So it comes out to be 62 minus 50. So it becomes plus 0.06. Similarly, delta T3, it is 2.62 minus 2.42. When you do it, it is again 0.20. So delta T4. Delta T4. What is delta T4? It is 71. It is 2.62 minus 2.71. I can take minus 0.09. It is 12. 8 plus 1, 9. Delta T5. I think still it's visible. Only one. I will write it. It is 80. 2.62 minus 2.80. It is going to be minus 0.18. So let me make a small correction. So this is going to help you. Yes, I hope it's visible now. So finally, when you take all these seconds, one is minus, plus, plus, minus, you take mod of delta. So mod of delta I'll be doing here. When I do this mathematics, the next mathematics is going to be mean delta time. Yes. Now when I take mod of delta T1 is going to be plus 0.01. Similarly, when I do this all thing, everyone becomes plus. So similarly, mod delta T2. So it is going to be plus 0.06 second. The next mod of delta T3, it is going to be plus 0.20. The third one, similarly, mod of delta T4 is going to be plus 0.09. So finally, the last one, mod of T5. So it's going plus 0.18 second. So what I mean to say, what is mod 1, 2, 3, 4, 5? This is called absolute error in the first time period, absolute error in the second time period, absolute error in the third measurement, absolute error in the fourth measurement, absolute error in the fifth measurement. So absolute error should be always positive. 0.01 second, 0.06, 0.20 seconds, 0.09 seconds, 0.18. When you add all these values, adding all these gives you a simple value. Let me write the mathematics. Okay, I hope T mean is written. Now we'll go for mean. T mean is calculated. Now we go for mean absolute error. Let me write it, mean absolute error formula. This value 2.62 already done. So let me erase it. The key point is here. Yes. Mean absolute error formula delta T mean. When you write delta T mean or write small t or capital T, there is no big issue. Add all these. When you add all these, you can write the formula like this: delta T1 plus delta T2 plus delta T3 plus delta T4 plus delta T5. When you add all these things, so and divide it by 5, you have 1, 6, 7, 27, 27, and 9, 36, 36, 54. I can write it as, yes, I can write 0.54 by 5. When you do the simplification, you will be ending up with 0.108. I can write it as, round it off, and I can make it as second. So this delta T mean, it is called mean absolute error. What is mean absolute error? Its value is 0.11 second. We got two things. T mean is 2.62, mean value of a time period is 2.62, and mean absolute error is 0.11 second, which helps me to calculate. I got absolute errors. Absolute error is here 0.01 second, 0.06, 0.20, 0.09, first part over, absolute error. Next, relative error I need to calculate. To calculate relative error, I need to go for mean value. Once I get a mean value, my formula says that, mathematical formula, relative error is defined as mean value, mean absolute value, that is called mean absolute error divided by mean value. What is the mean value? T mean. It is 2.62, means 0.11 divided by 2.62. Because your mathematics, I need to write it. Let me go for the next here. Yes. Now what is the relative error? Relative error, of course, you can easily understand. Relative error is defined as, relative error is delta T mean divided by T mean. What is delta T mean? It is 0.11 divided by 2.62. When you do the simplification, we'll end up with close to, I can say you, make it 11 upon 262, you'll get 0.04. This is going to be the value, 0.04. Relative error is going to be 0.04. Now, what is the next step? The last step is, what is a percentage error? Let me do this here. Once it is over, yes, this part I will erase now. Now finally, percentage error is defined as delta A, which according to the mathematics is delta A equal to relative error into 100. So finally, I will get an answer which is equivalent to, you can write the mathematics, it is 0.04 into 100. So which gives you 4%. So a relative error is going to be 4%. So I mean to tell, you have an experiment simple pendulum, you went for the time period measurement. Time period is defined as, let me recollect, time period is defined as time taken for one oscillations. We noted T1, T2, T3, T4, T5. I had different time periods and I took T mean, means T mean is the average value. When I get the T mean value, it helps me to calculate absolute errors. Absolute error in T1 I calculated, absolute error in T2 I calculated. Similarly, I have written here absolute error in T1 is 0.01, 0.06. Similarly, I got all the absolute errors. Once absolute error is over, individual absolute error, they are called individual absolute errors. Now go for a mean absolute error. What is a mean absolute error? Mean absolute error is defined as adding all the individual absolute error divided by the trial. We got the mean absolute error value is 0.11 second. Once that is over, what is the relative error? Relative error is defined as mean absolute error divided by T mean. T mean already calculated is 2.62. Then do the mathematics, you'll get in decimal places. Then once you multiply the 100, you'll get the final 1% error. This numerical gets over. I had a simple pendulum, I have done. Any doubt, you can ask me. I hope there are no doubts. With this, today's class I'll end. Thank you.